My name is Megan, and I designed my activity for a high school classroom as if this was their first time being exposed to quadratic functions. I'm assuming my students are native English speakers and have little to no prior knowledge of parabolas, and that they have Chromebooks to use Desmos on. I technically modified a lesson, but I only used 3 of their slides. My lesson students are scaffolded to discover what a quadratic function is, what transformations can take place on the parent function, and how it can model a real-world scenario. Students will experiment with the standard form of the equation, like y equals ax squared plus bx plus c, and then discover and narrate what each coefficient does to the graph individually. I assume that they know nothing about quadratic functions, but that they do know the basics of a linear graph, so we can work a bit off of that knowledge. So this is the first slide that I really liked from the other activity. It was creating the best fit line. So the idea is that you would drag these points to make a line through this curve. Then go on to the next one. You can see that it copies your line that you just made here, and then we can compare it. So it says here, lots of real world situations can be modeled by lines. The lines are probably not the best idea to use here. What does your original line say will happen to the football after it's kicked? This is kind of like a reality check. So then this third slide is the intro to quadratics. So this kind of shows that you should get rid of the line and put a parabola there, which they don't know that it's called a parabola yet, but put this curve here, which better models problems with gravity. So on the next slide is the key term parabola. This slide shows a picture of the parabola on the left, and then on the right, it says it's created by the parent equation y equals x squared and can be written in the form y equals ax squared plus bx plus c to allow for transformations. And then this right here is so the teacher can see what students are familiar with it and what students aren't. I mean, this is an intro to all parabolas. We're going with, most students are going to say no. The slide then is going to let them explore the first coefficient, a, in front of the x squared term. So this is one of the marble slides. You go this way, it'll affect the graph by vertically stretching it, but hopefully the students will get the idea to go the other way and notice that a negative a value turns the parabola upside down. On the next slide, we're going to have students conceptualize what just happened. Hopefully students will say something along the lines of, if it's negative, it goes upside down, because they don't have all the vocab yet, and then they can share it with the class. You can see what they said. They can see what other students said. The next one is exploring B. So adjusting B, in this case, I think that a lot of students would say, oh, the star's on the right. I need to go to the right. So the students are going to make B bigger, positive, just to realize that it goes the opposite direction. So B is a little bit confusing for a lot of students, I think, because it doesn't shift the way that you would think it would. So in the next slide, we kind of have conceptualizing B, and it shows standard form and vertex form, which is going to foreshadow what you would cover after this introduction activity. And then, did the slider B affect the graph how you thought it would? I would say most students would say no. So they click no, explain their thinking. Lastly, exploring C, we're hoping that because of their knowledge with lines and vertical shifts, they'll see that it's just a constant added by itself, that it just goes up and down. So hopefully they will go down. And on the next one, we are again conceptualizing this one with a multiple choice question. Share with the class. If a student put the wrong answer, then they will see other students with the right answer and their explanations. So hopefully they can learn from each other. And this is my challenge question, is to put together all of the concepts from the previous slides to make the parabola match the path of the football. So they'll have to move A, B, and C and transform the equation of the parabola in order to do so. There we go. So that was even hard for me. So that was embarrassing. But anyways, so you'll take these coefficients. On the next slide, the next challenge is to write those coefficients in your equation. So one observation about how the graph could better represent the path. And the hope is that they realize the parabola should not extend below the ground, which would allude to the next discussion of the vertex form, vertices in general, domain and range, like the overall properties of a parabola. And then I think it's really good for students to be able to ask questions. So yeah, that's my activity. And my design features would be that it's decently fun, since I included marble slides and a reference to sports. The other would be that it's good for learning. I think students that struggle with math would really benefit from how scaffolded the activity is. So yeah, that's my activity. Let me know what you think.